Welcome to the section on Infrastructure as Code. In this section, we will explore the concept of IAC and how it can revolutionize the way we manage infrastructure. We'll dive into the benefits of IAC, popular tools like Terraform, and best practices for implementing IAC in your organization. So let's get started and learn how to bring automation and efficiency to infrastructure management. Welcome to this lesson on infrastructure as code and its benefits. In this lecture, we will be discussing the basic concept of IAC and its benefits. What is infrastructure as code? Infrastructure as code, IAC, is a methodology that allows you to manage your infrastructure by writing human-readable code that describes the desired configuration of your infrastructures. This means that instead of manually configuring infrastructure components through a user interface, you define the configuration in code, which can be stored in a version control system, reviewed by other team members, and executed by an IAC tool to create and update infrastructure resources. It allows you to deploy infrastructure configuration using code instead of manually configuring its component. By deploying your infrastructure configuration through code, you can ensure consistency and repeatability in your deployment process. This eliminates the risk of human error, saves time, and allows you to quickly spin up or modify resources as needed. With IAC, you can automate the deployment of infrastructure resources, which ensures consistent and reliable deployment and minimize the chances of manual errors. By using code to define your infrastructure resources, you can create and update your infrastructure with ease without the need for manual intervention. This reduces the risk of human errors and ensures that your infrastructure is deployed exactly as intended every time. Now allow me to introduce you to some of the benefits of infrastructure as code. Consistency. IAC ensures consistent deployment of infrastructure resources regardless of the environment or infrastructure setup. This consistency is critical for large-scale deployments where maintaining control over its individual component is nearly impossible. Efficiency. With IAC, you can automate the deployments of infrastructure resources, which saves time and effort. This is especially true when deploying resources across multiple environments, which can be very time-consuming and error-prone. Risk reduction. IAC eliminates the need for manual intervention, which reduces the risk of human errors and ensures reliable deployment. This is particularly important for infrastructure security since a human error is often the cause of security breaches. Collaboration. IAC code can be stored in a version control system, which provides better collaboration across teams. This makes it easy for multiple team members to review and contribute to the code, guaranteeing that everyone is on the same page. Scalability. IAC makes it easier to manage complex infrastructure resources that consist of many components, ensuring that the deployment process is consistent and repeatable. This makes it possible to deploy resources at scale, even across multiple environments. The beauty of writing Terraform codes is that you don't need to know any programming languages such as Java, Python, or C++. Instead, you'll be writing much easier to read and understand declarative language. This makes it easier for infrastructure engineers to create and manage their infrastructure resources using Terraform without the need for programming skills. In the Terraform code snippet, you'll notice that we're declaring everything in sequence. We are telling Terraform to use the AWS cloud provider, and we're telling it to deploy a VPC. We are also providing it with the necessary inputs, such as a CIDR range or the IP range of the VPC, as well as the name to identify it with. Let me give you a more detailed explanation. In this example, the provider section defines the AWS providers and sets the region to US is 1. The AWS_VPC resource defines the VPC and specifies a CIDR block of 10.0.0.0/16. The output section outputs the ID of the newly created VPC. So basically, when executed, this Terraform code will create a VPC in your AWS account with the specified CIDR block. You can modify this code to create additional resources such as subnets or security groups, or use Terraform modules to create more complex infrastructure setups. In this lecture, we'll explore cloud-agnostic IAC, which lets you manage infrastructure with code that's independent of any provider. Terraform is a popular tool for this approach, allowing you to codify software-defined network configuration in HashiCorp configuration language or HCL. Let's learn how Terraform can help you manage infrastructure effectively. Cloud-agnostic IAC is a way of managing infrastructure using codes instead of graphical user interface. It allows you to define and manage your resources in a way that is not dependent on any particular cloud or infrastructure provider. This means that you can easily switch between providers or platforms without having to change your infrastructure configuration. Terraform is a popular tool for cloud-agnostic IAC that allows you to codify the configuration for software-defined network using a few lines of code in HashiCorp configuration language. HCL is easy to read and understand even if you have no prior programming experience, which makes it a great tool for infrastructure engineers and DevOps teams. One of the most significant advantages of Terraform is its versatility in interfacing with cloud and infrastructure vendors' APIs. Terraform supports a growing library of cloud and infrastructure vendors, including major public clouds like Amazon Web Services, Microsoft Azure, and Google Cloud Platform, as well as smaller cloud vendors like DigitalOcean and Heroku. This means that you can use Terraform to deploy resources across multiple cloud platforms and achieve high availability beyond what a single vendor can offer. Terraform's state tracking mechanism is another key advantage. It takes away the worry of dependency and resource tracking by keeping it all in one place. This means that you don't have to worry about how to make changes to your Terraform deployed infrastructure. Terraform handles the heavy lifting of deleting old resources and spinning up new ones to ensure that your infrastructure is always up to date and consistent. You can visit the Terraform website to check the list of supported providers. Thank you for taking the time to learn about Terraform with me today. I hope this tutorial has piqued your interest and that you consider using Terraform for your next infrastructure project.